in these examples, we will use Castigliano theorem to solve beam deflection. So here we have a beam, so horizontal beam fixed at left support. So if we say this support is A, and we have a hinge B, and at the point C, we have a concentric node P. And then on the right hand side support, if we say support D is a roller support. So the question is, we need to calculate the vertical deflection beneath the applied node. That means at the point C, we need to calculate the deflection. So there's a different method to calculate the deflection, but here we just talk about how to use Castigliano theorem to calculate the deflection. So the expression for the Castigliano theorem is shown here. So we have the deflection delta is equal to integrals. So in these integrals, we have a partial m over partial p. That means the partial differentiation of the bending moment over the node concentric node p, and m is the bending moment, and ei is the flexure stiffness. So first of all, we need to come out the expression for the bending moment m. Okay, so in these questions, they already provide the bending moment diagram shown here. So it starts from the, if we say here is point A, B, C, D. So at point A, the bending moment is minus PL over 2, and at point B is 0, and point C is PL over 2, and point D is 0. So look at this bending moment diagram. So we need two functions for the bending moment. So one expression is for this curve for the bending moment. If we say this is m1, and the other function is for this line is m2. Okay, because we have a discontinuity point at point C. So we need two functions. One is m1, the other one is m2. So if we just using the coordination system shown here, so the coordination system is, the orange of the coordination system is over here is at the point A, and this is y, this is x. Okay, so we can write down the function for m1. So m1, after some the derivation, we can easily write down the function of m1 is PL over 2 plus P over 2x. So x is larger than 0, less than 2L. So this is m1x. So you can derive it by yourself. I just skip the steps. And m2, we can also very easy to derive. The function is 3PL over 2 minus P over 2x. Okay, x is larger than 2L, less than 3L. Okay, this is the function or expression for the two curves m1 and m2. So then we can evaluate partial m over partial p. So we will have the partial m1 over partial p is equal to L over 2 plus 1 over 2x. Okay, this is partial m1 over partial p. And partial m2 over partial p is 3L over 2 minus 1 over 2x. Okay, after we got this expression, then we can plug in these two expressions into the Castigliano's theorem expression. So we will have the delta, so delta, if we say delta C, so is integral from 0 to 3L, because the length of this beam is 3L, is partial m over partial p, m over ei dx. So from 0 to 3L, we divided this bending moment diagram into two parts. So the first part is from 0 to 2L, and is a M1. So partial M1 over partial P is L over 2 plus 1 over 2x. So M is M1. So from 0 to 2L is this curve. Okay, this so is showing here. So this is M1. So we'll have M1 PL over 2 plus P over 2x. Okay, it's divided by EI. Okay, we can put it 1 over EI outside of the integrals. So we will do it later. So this is from 0 to 2L. And the second part is from 2L to 3L. And is the partial M over partial P is evaluated by M2. So partial M2, so it's over here, partial M2 over partial P is 3L over 2 minus 1 over 2x. This is partial M2 over partial P. And we multiplied by M2. M2 is 3PL over 2 minus P over 2x. We also need to multiply by 1 over EI and dx. Okay, now we need to evaluate these two integrals. Okay, let's do some arrangement. Okay, so look at here. If we take out 1 over 2 on the first bracket and P over 2 on the second bracket. So if we take out 1 over 2 or P over 2 for this first bracket and the second bracket, then in total if we take out this, we will have 4EI over P and 0 to 2L, then we will have x minus L and x minus L. Okay, so times dl. Okay, x minus L, we can write down as x minus L square. Okay, so now it becomes this. So similarly, if we just take out at the first bracket, if we take out 1 over 2, second bracket we will take out P over 2. Okay, take out these two, then we can write down the second integrals is expressed by P over 4EI 2L to 3L, and we got the first bracket is 3L minus x. The second is 3L minus x as well, and times dx. Okay, so 3x minus x, so if we write, so it's a square over here, so it's become this. Okay, we can also write down, so this is equal to L minus 3L square as well. So it's the same because it's a square. So we just make a change. So if we make a change here, so we write down this is x minus 3L. Okay, so now let's evaluate these two integrals. So we will have P over 4EI bracket, we will have 3x minus L cubed, so from 0 to 2L. Okay, this is first one. The second one, we take a P over 4EI, so we take out from here, so we move PL 4EI to here. Okay, so we got x minus 3L cubed to 3. Okay, so then after we evaluated these two integrals, so we come out, we find that the come out result will be PL cubed 4EI. Okay, so this is the deflection to the point C. The point C is beneath the concentric node P. So this is just by using the Castigliano theorem. So for this solution, for this procedure, we build up the coordination systems with origin points at point A. Okay, so now if we were using another simplified method to come out the expression for M1 and M2. So now I just want to show another method to build up different coordination systems. Okay, if I draw the, so this second, so if I draw, so if I draw the bending moment diagram, so okay, so this bending moment diagram is pi over 2, pi over 2. So this point A, B, C, D. Okay. So now I would like to build up a different coordination system to help us to simplify the procedure for Castigliano theorem. So I know I need to know the function for M1 and M2. Okay. So first of all, I build a coordination system over here. Okay, and the y1, x1. Okay. So then we can easily write down the M1 is equal to P over 2 x1. Okay. Then I build up the second coordination systems, and the origin point is on the point D. Okay, it's y2 x2. Okay. So then M2 can be expressed by the negative P over 2 x2. Okay, then we evaluate partial M1 over partial P is 1 over 2 x1. Partial M2 over partial P is equal to negative 1 over 2 x2. So after we know the partial M1 over partial P and M, we can just write down the Castigliano theorem expressions. So we will have delta C equal to 0 to the L. So the L is the length of the beam. So the length is 3L. So we just put L over here initially. So it's partial M over partial P, M over EI dx. Okay, this is the expression for the beam deflection using Castigliano theorem. So here we have two coordination systems. Then for fourth coordination system, it's changed from negative L to L. So it's changed from point A is negative L to C is positive L. Okay, so the partial M1 over partial P is 1 over 2 x1. Okay, M is P over 2 x1. Okay, times EI dx1. Okay, this is the first part. The second part is for the M2. M2, we build up the coordination systems is y2, x2. And it's changed from 0, no, not 0, is 1 minus L to 0. So it's from C to D. C is negative L or minus L at this new coordination system y2, x2. C is minus L. Okay, D is 0. Okay, from negative L to 0. And the partial M2 over partial P is negative 1 over 2 x2 times negative P over 2 x2 times 1 over EI dx2. Okay, so then we can evaluate is, so it's here is 1 over EI, so it's P over 4 x1 square. So minus L P over 4 x1 square and dx1 times minus L equals 0. is p over 4 x2 square dx2. Okay, so this is the integral. So if we evaluate these integrals, so we put over here, so we will have 1 over ei, we'll have a bracket, is 12 p over 12 x1 cubed l minus l plus p over 12 x2 cubed negative l 0. Okay, we can easily evaluate these two terms. We will have 4ei p l cubed. Okay, so we can see the second procedure. We build up the two coordinate systems x1 y1 x2 y2. By using these two coordinate systems, we can get a simplified expression for m1 and m2. So this will help us to speed the procedure to evaluate the integrals. Okay, so this is the question to calculate the deflection at the point on the beam by using Castigliano theorem. So we're using the two different procedures. So by using different coordination systems. Okay, so this is the solution for this question. Thank you.